Greetings everyone. I hope I find you well and you're doing well together with your families. Welcome to our usual Tuesday 7 to 8 p.m. exam tips, and today we are focusing on indices. Alright, so indices is one of the major topic which many students, especially those who are writing this year, could be the checkpoint, the Form 2s, or the Form 4s, the IGCSE, or the O-level students. But I want to prove to you or to show you today that indices is not as difficult as you might call it. It's just a challenging topic. So let's look at the principles or the fundamentals of this chapter, laws of indices. So let's write indices. All right. This word indices is coming from the word index, or in other ways you can say indices is a plural word. Alright, so the singular is index, of which the word index is singular. So this word indices simply means these index, they are now many, and now they are called indices. Alright, just like when you want to say a bag, now if there are many, they are bags. If you want to say a boy, that is singular, then when there are many, they are boys. Alright, basic English. A girl, then when there are many, it's girls. Alright, so now that's the same thing with indices. So today we want to highlight how do we deal with indices. So I want you to understand these basics, because a lot of students, the reason why they hate mathematics, or the reason why they find mathematics a difficult subject, is because maybe perhaps they have never been taught basics. So the blame is also laid on the teacher as well. Alright, so now I will try the best I could to tell you or to explain the basics of indices. So the first things first, indice is a singular word. Now, but what are indices? What are indices? So let me write this as a question. What are indices? We only know indices as a chapter, but what are they made of? Alright, so I'm going to write an example. An indice is a number composed of a base and a power. Let me answer the question. This question, I'm going to answer it below. An indice or an index, all right, is a number that bears or that contains, number one, it contains a base. It's a number that contains a base number. We call it a base number. And it also contains a power. So the combination of these two gives an index. So if you're asked at school or by your younger brother or younger sister, tell us what is an index? You say an index is a number that bears, number one, a base and a power. All right. So let's look into more examples of indices now in terms of real numbers and powers. All right. Now, suppose you're given a number like 9 to the power of 5. This is an example of an index. 9 to the power of 5, or you might be given 10 raised to the power of 2. We can call it 10 squared. Still, it is an example of an index. So this number 9 is what we call the base number. This is what we call the base number. And this number 5, the 5 that is at the far right corner of 9, is what we call the power. Alright, this is the power. So this is a typical index or an index. So these are indices. So singular is just an index. Similar to this 10 squared, this 10 is a base number. And this 2 is the power. Alright, I'm sure we are together now. We now know what an index looks like. Alright, if I'm to ask you, can you tell me what maybe a Lamborghini, how does a Lamborghini look like? You say it has got doors that flips like this. If I ask you, can you tell me how do I know this is a Timberland and this is a Nike Jordan? You tell me that a Jordan has got this sign, a Timberland has got this sign. So similar to indices, we want to take it from that point. Indices, how do you know that this is an indice? They have got features, they have got characteristics. Number one, they've got a base number, and this one has got a power. Similar if you want to tell me about shoes. You guys, you know shoes better than me. So if I ask you about a particular shoe, you are quick to say, it has got this symbol and it has got this color, you know that. So similar to these indices, when you see a number like this, just know that this is a base number and this is a power. All right? Are we together? Okay. Now, let's move forward now. So the first thing that we want to discuss that is connected to exam tips, the tip number 1, is to know the laws of indices. So before we go even further with the calculations, the first tip that I'm going to give you tonight is for you to understand the laws of indices. So let me highlight these tips as 1, laws of indices. That's the first tip, laws of indices. So this chapter is governed by laws. This chapter is governed by laws. That means if you don't abide by these laws, then you are not going to be awarded marks. In other words, you have committed a mathematical crime, so to speak. So for you to pass mathematics, particularly on this chapter, you need to follow the laws. You need to respect the laws. So there are about 7 laws of indices that I'm going to highlight, but I'm going to highlight them very slowly for the benefit of the viewer, because if I just write them randomly, then you might not be able to grasp the concept. So let me first of all let you understand what a law is. All right. So a mathematical law is a statement that is irrevocable. Okay? Meaning it cannot be changed. The laws that I'm about to teach you here cannot be changed, be it in ZIMSEC, in Cambridge, or in Oxford. The laws are the same. All right? As long as it's mathematics, the laws are the same as far as laws of indices are concerned. Now, let's look at the law number 1 now. So the first tip is the laws of indices. So I'm going to teach you on law number 1. What does law number 1 say? So let me highlight here, law number 1, laws of indices. Maybe perhaps let me just write few sentences, just a short sentence here, a phrase, before I write the laws. All right. These govern the topic. As simple as that. These laws, they govern the topic. As long as you don't know the laws, then you fall on the sideways. You are not on the right track. Okay. Now, let's write the law number 1 now. So what does law number 1 say? Law number 1 simply says, when multiplying numbers of the same base, we add the powers. Remember we said an index has got a power and a base. So the law number 1 is clear. And what does it state? I'm going to write it now, just like what I've said. Right? It states that when multiplying numbers of the same base, we add the powers. All right. So when we are multiplying numbers of the same base, we add the powers. Let's hope the spellings are correct there on multiplication and add. All right. So, which means if I have a number like, suppose I have 9 to the power of 6 multiplied by 9 to the power of 3. The first thing I have to see here is the base. For me to apply law number 1, I have to pay respect to the base. Remember, the base is the bigger number and the power is the smaller number at the far right corner, okay, of the number. So what do? I don't need to take a calculator. Remember, in this chapter you are advised not to use a calculator. I've said this a lot of times to students that I teach, including you as well, that when you are dealing with indices, avoid to use the calculator because the examiner will see that and you are not awarded marks. It's very clear that this student or this candidate was using a calculator, so you are not awarded marks. What they want to see is the calculation that I'm about to make here, where you have to pay respect to the base. So it's like we're saying 9 to the power of 6 plus 3, and the final answer is 9 to the power of 9. That's the answer. See? So that's the first example. I hope you are getting this. 9 to the power of 6 is being multiplied by 9 to the power of 3. So our product will be 9 to the power of 9. How? We are saying we just deal with the powers. We add the powers. So that's law number 1. Let me show you another example, maybe without using maybe numbers. Let's use maybe unknowns. We know in algebra we have what we call unknowns, and unknowns are simply letters of the alphabet which represents numbers. What about if you are given m to the power of 5? M to the power of 5 multiplied by m to the power of 3. M to the power of 5 multiplied by m to the power of 3. It's very clear. You have to pay respect to the power, to the base rather. The base. They are identical. That's the key thing. That's tip number 1, remember. The base should be identical. So if the base is not identical, don't apply law number 1. We'll see as we continue with these laws which law you are supposed to apply when the bases are not the same. So this time we are going to say m to the power of 5 plus 3, and we have m to the power of 8. Very simple. Okay? So this is very simple. So I know most of the students, they don't have problems with law number 1. But as we continue with the laws now, that's where many are challenged. But today I know it will be different because the laws will be explained very clearly. So don't worry. Now, let's move on to law number 2. We're still on tip number 1. We say tip number 1, you have to know the laws. So a lot of students have been asking, so will I be given the laws on the exam sheet? Okay, the list of formula paper, are they laws of indices? The answer is no. The laws of indices are not provided on the sheet. Okay, so you have to know the laws of indices by heart. It's very easy to know that. Remember, I said there are 7 laws already. You are now in a position to understand law number 1. Let's move on to law number 2. Law number 2 is about division. Law number 2 is about division. Alright. So before I go to law number 2, let me just get to law number 1 again. Let me correct an error, the common error which many students make. Right. Remember, we said m to the power of 5, the last example, multiplied by m to the power of 3. Right? And you get m 5 by 3, 5 plus 3, because we are adding the powers. And we have m to the power of 8. Now, a lot of students now, they misunderstand the concept by saying, now m to the power of 5 multiplied by maybe n to the power of 3. And because they haven't noticed that the base has changed, as long as the base is not the same, law number 1 cannot be applied. It can only be applicable when the bases are the same. So the answer here cannot be mn to the power of 8. No, this is not correct, but this is correct. So when it's like this now, that means we are going to apply a different law. We shall see as we continue with the laws. But for now, I want you to understand that law number 1 is only applicable, or it can be made use if we have the same basis. All right, I'm sure that is clear now. So the common error is corrected. Now let's move on. We want to move on to law number 2 now. Law number 2 in words can best be described as follows. When dividing numbers of the same base, again, the key word is same base, we subtract the powers. We subtract the powers. I hope the spelling for powers is, you can see it clearly there. We subtract the powers. Right. I'm going to highlight the keyword same base and subtract. These are the keywords. We know in English or in any language, when a sentence or a phrase is jotted down, there are keywords. All right. So the keywords that we are seeing here, and these keywords, they gives us the meaning or the idea behind what we are discussing. So the same base, meaning that if we are not having a same base, just like the common error that I have highlighted in the first law, the same thing applies here. Let's look at this example. E.g., if I'm given m to the power of 8 divided by m to the power of 2, what am I going to do? We look at what the law is saying. Let's look at the demands of the law. The law is irrevocable, like I said. You cannot change it. Okay? So it stays like this. Let's look at the division sign. The moment you see the division sign, you have to assume that it could be law number 2, which we are supposed to deal with. Remember, I said the laws are not given in the exam. So you have the laws in your brain. At the moment you see a question like this, you say, okay, these are indices. That's number 1, to identify the chapter. Number 2, you say, let me use tip number 1. Do I know the laws? You say, yes. Law number 2 says when dividing numbers of the same base, we subtract the powers. So let's look at this now. We are going to say m, you just write m once. Then you look at the powers, because the powers are the main thing. 8 minus 2. And our final answer is m to the power of 6. This is easy, right? In most exam questions, I'm looking right now at a Cambridge past exam paper. You see that most of questions like this, you are given 1 mark. The mark allocation is 1 mark, meaning that you don't have to calculate that much. The mark allocation says a lot on how far you should calculate. In any mathematical problem, check the mark allocation. It should give you a greater picture of how far you should go with your calculation. Right. Let's continue. We are not yet done on law number 2. Let's look into more examples. So some people are confused with negative numbers. The moment a negative number, that is directed number, is introduced, they are confused. But I'd like to encourage you that you need to work on your directed numbers. You need to work harder, and you see that if you do like that, practicing, and it becomes easy and easy. Mathematics is a subject of constant practice. You have to practice constantly. All right, doesn't matter how difficult it might look like, but the moment you continue practicing, checking advice to teachers, and get assistance from other students, perhaps one of your colleagues will be understanding the chapter. That's how you get to know the subject. All right. What if I'm going to show you the same example, but this time I'm using a negative power. right? So this is negative 2. 8 to the power, m to the power minus 8 divided by m to the power minus 2. The first thing is to identify the chapter. This is a typical example or question on indices. But let's look at the law to apply. We have to apply law number 2. So, by applying law number 2 now, we simply write m, then we say minus 8. Because there's a minus that I should write here, which is a fixed minus. Then there's also a minus 2 here. So, we are now checking the negative numbers now. I'm sure you can agree with me that when a negative and a negative, they collide, they form a plus. Okay, this is simple algebra. So at the end we have m to the power minus 8 plus 2. Right? So minus 8 plus 2 gives you minus 6. Minus 8 plus 2 gives you minus 6. So the final answer is m to the power minus 6. So that's how this example differs from the first one. This one now has got negative powers. But the negative powers should not frighten us. We simply follow the algebraic rules, the algebraic principles. When a negative and a negative collide, we form a positive. Then you write your positive, and the examiner will be keen to see all this. You have to convince the examiner that you know algebra. Okay, remember I always say mathematics is like you are in an interview. You are convincing the one who's interviewing you that you know the job. So that's the same thing here. You want to pass mathematics. So you are like in a court and you are facing the judge. The judge is the marker. So you have to convince that you are not guilty by writing the correct thing. So these are the laws of indices. So I'm just here standing like a lawyer, just helping you on how to convince the examiner in attaining full marks, similar to the court. All right, I hope we are to get on that. Now, we want to quickly move on to law number 3. But for those who have got questions, don't burn with questions. I don't want you to keep your burning questions with you. You need to follow the steps or just log on to our Facebook page and type your name, or you can type your number, and then you can type the topic that is giving you problems. Then we'll be happy to discuss it during this Tuesday studies. I'll put that chapter in our next Tuesday studies as we go. All right. Now, let's move on to law number 3. Law number 3 is very simple. Law number 3 is very simple. It says any number raised to the power of 0 is 1. Law number 3. Any number raised to the power of 0 is equal to 1. All right. So it doesn't matter how small the number is, doesn't matter how big the number is, as long as it's a number and it's raised to the power of 0, then the result is 1. For example, if I say n to the power of 0 is equals to 1, it doesn't matter we don't know what n is, because it's standing for a number. So we know the result will be 1. What about 1,000? 1,000 to the power of 0 is also equal to 1. What about minus 2 to the power of 0 is also equal to 1. But some calculators, if you say minus to the power of 0, it's error. But it's mathematically correct to say minus to the power of 0 is equals to 1. Although some calculators, they reject that. It depends with the calculator. Right. But what I want you to understand is that whatever the number that you might think of, just know that when it's raised to the power of 0, it is equals to 1. What about t to the power of 0? It's equals to 1. What about v to the power of 0? It's all equal to 1. What about 10 raised to the power of 0? 10 to the raised to the power of 0 is also equal to 1. So whatever number that you might think of, just raise it to the power of 0, the result is equal to 1. All right. So we want to fuse these laws. I'm sure you understand that at one point laws, they fuse. Okay, what does that mean? They mean that sometimes these laws, they are joined. Okay, so law number 3 can be joined with law number 1 or 2. So I'm going to illustrate that still under law number 3. Let's look at law number 1 and see if we can be able to remember what law number 1 says. Remember I said 10 raised to the power of 2 multiplied by 10 raised to the power of 0. This question can be solved using law number 1. So that's the method 1. We can use law number 1 by saying 10 to the power of 2 plus 0, because we are adding numbers of the same base, and we end with 10 squared. Okay? We can also choose to move with a different path, and I'm going to call that path method 2. So 10 to the power of 2 multiplied by 10 to the power of 0. I'm going to acknowledge that 10 to the power of 0 is 1. So I'm going to rewrite it again by saying 10 squared multiplied by this is equal to 1. And we know whatever number that we multiply by 1 remains that number. So the answer to that now will be equal to 10 squared, which is the same as this and that. Same thing. So it's just an alternative route, but it will give us the same answer. So we can see that these laws are real because they can be used simultaneously and still get the same answer. Alright, so I know you know the meaning of simultaneously in mathematics. That means together. That means 10 squared is the answer in both despite the method used. Alright, I hope we are together on this one. So we are done with law number 3. Remember we said we have 7 laws, meaning we still have 4 to go. Alright, so let's look at law number 4. Let's look at law number 4. What does law number 4 say? What does law number 4 say? Law number 4 is called the law of negative power. The law of negative power. Law number 4 is called the law of negative power. So let's write law number 4. The law of negative power. So I'm sure I know I've introduced negative powers earlier on, but I was illustrating based on the basis of law number 1. But now we are focusing on the negative powers only. And in most cases in the exam, you'll be given like this, maybe 10 to the power minus 3. And they say simplify 10 to the power minus 3. So one thing I can tell you here is that in mathematics, it's much easier to deal with positive powers than negative powers. So the moment you're given a negative power in indices, the number 1 goal is to change that negative power to a positive power. So that's the thing. So this is where law number 4 is put in place now. So this is where we introduce law number 4. So it is very simple. One thing I want you to understand is that you have to, in other ways, we are being told to change. When they say simplify this, in a simpler way, they are saying make this number positive. In some questions, they write it like that, make this number positive. So how do you make it positive? You simply say 1 over 10 to the power 3. 1 over 10 to the power 3. I want you to write it first, then I'll explain. Alright? This is the answer to this. That's how we make it positive. Alright. The illustration or the explanation here is that the equal sign simply means this is the same as this. They wanted it to be positive, so we have to say 1 over, we borrow a 1. This 1 is borrowed, this one. Many, they think it's coming from nowhere. No, it's not coming from nowhere. It's borrowed. It is a law, it's a fact. Okay? So I don't want you to think deep about it. Just know that when we want to make this positive, we borrow a 1 and leave it here. Then we put our 10 to the power of 3. But now, can you see now it's positive now? I'm going to repeat because I know many now, they are boggled now. They say, but what is it that he's saying? Let's have another one maybe. M to the power of minus 6. Okay? Then this is equals to 1 over m to the power of 6. Can you see now the bottom number, it becomes a fraction. The bottom number is now positive. This is what we want. The bottom number is now positive. So we've made this number positive. We've made this number positive. So this is very important. Let's look at more and more examples on this, because we still need to understand how to deal with negative powers. All right. Let me give you another one. Okay. You may be given a to the power of 4, a to the power of 4, divided by a to the power of 2. Right. To the power minus 2, rather. So, two methods can apply here to solve this. The quicker method is to apply law number 2 and say we are dividing numbers with the same base. So we subtract the powers. So we have a to the power of 4 minus, but remember there is another minus 2 here, minus 2, and the answer is a to the power of 6. That is the answer. Remember there is a fixed minus. If there was a 2 here, you say 4 minus 2. And you get 2. But because we have a negative 2, so we have to respect the directed numbers, minus and minus, and we get 6. So if you know that you have problems with directed numbers, you have to find help, because this is serious. At this stage, the examiner is not expecting candidates to have problems with directed numbers. All right? I don't want to discourage you, but I'm rather encouraging you that it is high time now that you get to understand these directed numbers. All right. So let's have this one. I'm going to say this is method 1. Now we have method 2 now that we want to apply on the same question. Method 2. Right, remember we have a to the power of 4 divided by a to the power of minus 2. I can change the a to the power minus 2 applying law number 4 and say a to the power of 4 divided by 1 over a squared. I hope it's very clear from that end. Maybe let me write it again here. A to the power of 4, a to the power of 4 divided by 1 over a squared. Right. I know that if I have a power which is negative, I can make it positive by saying 1 over a squared. 1 over that number, and it becomes positive. So in other ways, I can now rewrite this by saying this is the same as a to the power of 4 divided by a to the power of 2. A to the power of 4 divided by a to the power of 2. But not exactly as that, because we know that the rule says when we have a number like this, we invert the divisor to make it positive. So I'll end up having a to the power of 4 multiplied by this. I'll invert the divisor and say a squared over 1. Then I'll say we add the powers and we end up having a to the power 6. Alright, this is not the route that I would choose to take even in the exam. No wonder we call it exam tips. Don't choose method 2, although it's going to give you the correct answer. So this is the reason why I have to deliberately introduce law number 4 in this particular question, which really doesn't require law number 4. It requires law number 2 only. But because many students have seen in the exam as an invigilator, seeing people trying to fit in law number 2. But now when it comes to the algebraic part of the inverting the divisor or reciprocation of the divisor, it becomes a problem. They fail to solve it here. But me, obviously, I can be able to solve it from here. But many students, they have problems now here. So if you know that you can't go through this channel, this is not the route for you. It becomes a dead end. So we are going to remove method 2. But for those who can understand it, it's fine. But many students, I don't advise them to take this route. Although it's going to give us a correct answer, you better have to stick with law number 2, like this. Right, are we together? Okay, I hope we are together, and I hope you're getting what I'm saying. All right, now let's continue with law number 4. Law number 4 goes on to say, let me pick a question from the exam paper, which I have here with me, fractional negatives. Sometimes you may be given a question of this type. You may be given a question of this type. They may give you a question of this type. They say, solve 2 over 3 raised to the power of minus 2. Yes. This is now a fraction. The base is a fraction. And the power remains negative. It is a negative power. So this is where many are frightened. One other thing in mathematics, you have to build courage. You have to be very strong mentally. Okay? That's the other thing for mathematics. It's very crucial for you to be strong mentally. Okay. So, I'm not teaching you to be overconfident. No, I want you to remain confident only, but you have also to be strong mentally. Okay, so there's a big difference there. Now, here, the first thing that I have to understand here is to check the base. So the key is to check the base. I'm going to check the base. That's the first thing. The second thing, also I have to acknowledge the power. Acknowledge the power. 2 things. So if I check the base, and I'll see that the base is not a usual one, it's now a fraction. And I'll check the power. I say the power is not a usual one. It's very unusual. It's a negative power. So this question requires deep analysis. Don't just jump and answer questions like this without deep analysis. Because remember, we said in Cambridge, the answers are on your fingertips. So if you can't get the answers from the fingertips, then in most cases you don't get it right. So the first thing, or the fingertip number 1, is for you to understand these 2 things. Check the base and acknowledge the power. Now, let's look into that. Now, so for me to check the base, I know it's a fraction. And for me to check the power, I can see that it's negative. So how best can I come up with the answer? I have to make this power positive. I have to make this power positive. Okay? I have to make this power positive. I have to make this power positive. Alright? How? By saying 1 over, I'm going to change the marker so that it's very clear, 2 over 3. But now it's now positive. I want you to look at this very closely. There was no over 1 here, and the power is negative. So in other words, I have to rewrite it in positive terms. I have to make the power positive. by saying 1 over 2 over 3, but now the 2 is now positive. Remember I said earlier on that in mathematics, it's much easier to deal with positive powers than negative powers. In many cases, when you try to work with negative powers, it will be a long route and it becomes tedious. And in most cases, you get the answer not correct or incorrect because of the channels that you will be taking. So avoid taking longer routes and also avoid shortcuts, but go on the highway. That's what we say. Go on the highway. Don't go on the shortcut, or also don't go on the longer route, but go on the highway, the right, correct way, or the path. Okay, now let's move forward. So now I'm going to move forward by saying now the 1 remains there. But now the 2 or the square is going to affect both the numerator part, which is 2, and the denominator part, which is 3. So in other ways, it's 2 squared, which will give us 4. Check 2 times 2 squared is 2 times 2, that gives us 4. Over the same 2 now also affects the 3. So it's 3 times 3. 3 squared is 3 times 3. This gives us 9. Right. So this is where we are now. We are at 1 over 4 ninth. 1 over 4 ninth. For those who know reciprocation of numbers, we know that when we have 1 over 4 9 is the same as 1 divided by 4 over 9. So when we have 1 divided by 4 over 9, kindly come to this side now. I'm going to show you from this side the manipulation of numbers here. We are going to say 1, this is the same as 1 divided by 4 over 9. And it will give us 1 multiplied by 9 over 4. And the answer is 9 over 4. Or 2 1/4. As simple as that. This whole thing, or this whole setup, which is here, is the same as this part. Right? This whole setup here is the same as this whole setup, which is here. This one. Right. So how do I solve that? Or simplify it? That's the correct word, to simplify it. 1 divided by 4 over 9. You say 1 multiplied by, this becomes you invert the divisor and it becomes 9 over 4. And 1 times 9 over 4 remains 9 over 4. 4 into 9 gives you 2. Remainder 1/4. Alright. But in future, you don't have to go through this channel. This is a channel, a thing of the past, if I may say. We used to do this in primary school, but this at IGCSE or at checkpoint, you don't have to write like this. If you're Form 2, you understand that this is no longer used now. If you're in Form 4, the West, you understand that we can simply deal with it in a direct manner. When it's like this, you just take your 9 multiplied by 1 divided by 4. So you can actually use this quicker route by saying 1 times 9 divided by 4, and still you get 9 over 4. So this 9, it seems like it goes to 1. Right? That's how it is. The bottom number goes to the top and it multiplies the 9. So that means if there was a 2 here, it was going to be 2 times 9. But because there is a 1, we say 1 times 9, which is 9 over 4. And still we get 2 1/4. Right, I hope this is clear. And I hope you can hear me clearly there. The audio is right and the picture quality is also right. Or the video quality is also right. Now, let's get ready now to law number 5. Alright? Let's get ready to law number 5. So this is where we are going to end in law number 5. Then in our next lesson, we'll be talking about law number 6 and law number 7. I know some of you now, I don't want to overload you with information. I want, as long as you can get law number 1 to 5 for now, then next week, Tuesday again, we continue now with law number 6 and law number 7. Alright, so law number 5 is called the product of indices. Law number 5. Law number 5 is known as the product of indices. Alright, the word product means when we are multiplying, the result is the product. The answer that we get in multiplication, or the number that we get after multiplication, is what we call the product. So it's very clear, self-explanatory, product of indices. Example of this is when you have a number like 5 raised to the power of 2 multiplied by 3. 5 raised to the power of 2 in a bracket multiplied by 3. So this we can apply the product of indices. How? Because we look at the powers now and we simply say 5, 2 by 3, and the answer is 5 to the power of 6. Don't simplify it further, because remember you don't have a calculator. So don't simplify it further by saying 5 to the power of 6 and you get the answer. This is where many are caught in the exam now. Examiners can easily trace that you're using calculator, because some are now, they will now calculate this now and get a number. Like for example, if you say 5 squared, you get that number. So you have to end it here. This is the correct answer. So law number 5 is very simple. Law number 5 is very simple. It's a law that you have to focus on the powers only, not on the base. In most cases, they don't give you 2 bases, they only give you 1 base and also several powers. Let's have more examples of this. I hope you're getting this. Maybe you can have a number like maybe v, it's an unknown, to the power minus 2 times 5. I will raise the power 5. Typical example of law number 5. How law number 5 can be applied. Right. So v minus 2 to the power of 5. V minus 2 to the power of 5. Right. How do you deal with this? Number 1, you leave your, remember I said the base is, normally they give you just a single base. Then the power now, minus 2 multiplied by 5. The answer is v to the power minus 10. Alright? Or 1 over v to the power of 10. They have applied law number 4. Can you see that? But you can also get marks even if you leave it here. Unless if they say, simplify this and make the number positive. This is where maybe you can take it now to this. So this is why I say there's a connection between these laws. These laws are connected. So you have to get ready. You have to understand the laws one by one. Okay? You don't need to rush in mathematics. The reason why many, they dislike the subject is because they want to rush into grasping concept. It's a process. It's not a day's event. After you've learned from this tutorial, you don't need to rush and say, I have to get it at once. No, it takes time. It takes time. But the time frame that we have now, this is what we want to deal with, and you have to get it fast so that by the time the exams are upon us, you will now be able to solve these problems. Right? So don't worry, you become a champion in this subject. You become better and better as we go. All right. So we would like to take it to this point for law number 5. Remember, I said law number 6 and law number 7. We'll explain it in later topics. But let me just give you an insight of law number 6 and law number 7. Then next time we'll just grill on as many questions as we can in law number 7. So law number 7 and law number 6, there's a thin line between these two laws. They are called fractional indices. All right. Law number 6, we call it the law of fractional indice. The law of fractional indice. The law of fractional indice. or index, right? Remember, it's just singular. Where you are given, I want you to understand the principles of this. When you are given a number like 2 to the power of half, when a number is raised to the power of half like this, you look at the fraction. So we know a fraction is a number which has the numerator and the denominator. So according to this, the numerator is 1 and the denominator is 2. Denominator. And this is the numerator. Okay? So the main focus on law number 6 is the power. Okay? So the power bears a fraction. And just like I said about negative powers, when you are given a number or an index with fraction, which is fractional, the main thing is to convert it or change it to become a non-fractional number. So according to this now, we look at the base, which is 2, and we look at the power rather, and say this is 2, and this is the same as the square root of 2. Okay? Meaning that if I was given 4 raised to the power of half, the answer was going to give us the root of 4, which is equals to 2. And all the fractions that we have in law number 6, they have a power which is 1. The power is not going to exceed 1. Law number 6 is the law of negative, is the law of fractional index with a power with a numerator less equivalent to 1. Okay? So in other ways, in practice, we will be saying this 2 now is the one that comes to the square root sign, and we don't write 2 here, we just write a square root sign. But this 4 is being affected by 1, which is the top number. But this 1 is no impact, it will just remain as 4 squared and becomes 1. Alright, let's look at another example of law number 6. Law number 6 can come in different ways. For example, we can have 16 over 81 raised to the power of half. Right, so in other ways we can rewrite this by saying this is the same as the square root of 16 over 81, all raised to the power of 1. The 1 now remains there. What comes to the square root sign is the 2. Okay, we know any number raised to the power of half is the square root of that number. Alright, so the answer to this now will be equal to, we know the square root of 16 is 4, the square root of 81 is 9. So the answer is 4/9. That's the answer to this one. So we are done at this point. Alright. But let's look at some of the complex numbers, because they don't just come like this. It's not as easy as like this. Sometimes you may be given a number or to the power of a quarter or from a third. Okay? Still the same thing. Okay. So now let's continue. You may be given 8 to the power of a third. Simplify this, 8 to the power of a third. Okay? So how do you simplify this? We know that we cannot go anywhere dealing with fractions, but less we introduce the square root. Okay? Or this time we are not going to introduce the square root because it's a 3. We introduce the cube root. This is when we write a 3 now. When it's a 2, we don't write a 2 here, but when there's a 3, 4, 5, and so forth, that's when we put the number here. So this simply means the cube root of 8. This means the cube root of 8. Remember, no calculators allowed. But if you were to punch on a calculator the cube root of 8, you get 2. You're looking at a number that you can multiply 3 times to get 8. and that is 2. So if you say 2 times 2, you get 4. 4 times 2, you get 8. So the cube root of 8 is 2. So 2 is the answer to this one. Alright, I hope we are together in this one. So it goes on and on. We can introduce negative powers as well. We can also introduce negative powers. It's also possible. For example, remember there's a connection in these laws. Law number 4 can also be applied here together with law number 6. For example, maybe 27 to the power of minus 1/3. Now the first thing is to see the negative power. That's the first thing that you should see. And say, I have to make the negative power positive. I want you to say it in your heart. Whenever I see the negative power, I have to make it positive. How is that possible? You say 1 over. 1 over everything. So this will be 1. This 1, remember, is a borrowed 1 over everything. 27, but this becomes positive now to the power of 1/3. 1/3 is now positive, which is our main goal. So we've achieved our goal to make this positive. So law number 4 has been applied. Now, we can now change it and say the 1 remains there, but now we need to deal with the cube root of 27, because this means the cube root of 27. Cube root of 27. What is that number that we multiply 3 times to get 27? What is that number that we multiply 3 times? Is there a number that we can multiply 3 times to get 27? So with practice you end up knowing these numbers. But even if you don't know the number, you can ask yourself, maybe you can start maybe with a smaller number like 2 and say 2 times 2 times 2 gives us 8. So 8 cannot give us 27. Let's move on to 3 maybe. 3 times 3, it will give us 9. 9 times 3, it will give us 27. So you start with the smaller numbers moving forward. So if 3 cannot give you that, you can go to 4. But in this case, we are lucky because 3 times 3 gives us 9. 9 times 3 gives us 27. Meaning that the cube root of 27 is 3. The number that we can multiply 3 times to get 27 is 3. So the answer now, I'm going to take it from there to here, is going to be 1 over this whole thing. 3 cube root of 27 is 3. So the answer is 1/3. Okay, I hope we are together in this. Alright, I know what I've said is a lot, and you have a lot to learn, a lot of bones to chew, a lot of stuff to digest. So I don't want to overload you with information. I know our 1 hour is almost done now, from 7 p.m. to 8 p.m. every Tuesday. So meaning that we'll continue on law number 6 and move on to law number 7. Like I said, if you can understand law number 6, law number 7 will be easier for you to understand. Thank you for joining us here. We'll see you next time. Remember to like our Facebook page, our Instagram, as well as log on to our website www.MaryAnneSchool.com. There you'll be seeing future events and also lessons that we'll be having. If you have any questions, feel free to send a message on WhatsApp. If you want to join these free classes, just type in our WhatsApp number, Maths Tuesday. Then we'll be able to log you to other different platforms like Zoom, like Viber, like WhatsApp. We also have lessons on WhatsApp sometimes. So the one-on-one lessons as well, you are also free to join. If you connect with us, we'll be able to tell you what is required for you to join the one-on-one lesson. Thank you very much. Enjoy the rest of your Tuesday. Good evening to you and goodbye.